For centuries, the English Channel was a barrier that separated two great nations, Britain and France. Connecting them beneath the sea was a dream that many called an impossible engineering nightmare. In 1986, the project was finally approved, a $15 billion bet against the power of the ocean. The scale was unprecedented. Workers had to dig deeper and further than ever before attempted in history. To bite through the solid rock, engineers built massive machines as long as 2 football fields. 11 of these giants were lowered into the earth, 6 from France and 5 from Britain. Engineers targeted a specific layer of rock called chalk marl, strong enough to hold, yet soft enough to cut. The machines began their journey into the darkness, crawling forward at a few feet per hour. The design consisted of 3 separate tubes, connected every few hundred meters for safety and ventilation. Thousands of workers spent their days hundreds of feet beneath the seabed, far away from the light of the sun. To ensure the 2 sides met perfectly in the middle, they used cutting-edge laser guidance systems. On the French side, the rock was fractured, causing terrifying high-pressure water leaks that threatened the entire project. Millions of precast concrete segments were used to line the tunnels, each designed to last over a century. The waste rock removed was enough to build a small mountain. It was used to create new land on the British coast. After 3 years of digging, the moment of truth arrived. The 2 sides were just inches apart. December 1990, the first breakthrough occurred. For the first time since the Ice Age, Britain was connected to Europe. It was a historic moment of peace and engineering brilliance, achieved entirely beneath the ocean. Once the digging was done, the massive task of installing hundreds of miles of electrical cables and steel tracks began. Safety was the #1 priority. The tunnel was equipped with the world's most advanced fire detection and cooling systems. Specially designed shuttle trains were built to transport cars, buses, and freight trucks across the border in minutes. The Eurostar transformed travel, allowing passengers to go from the heart of London to Paris in just over 2 hours. To prevent air pressure from slowing the trains, engineers built relief ducts to allow air to move between the tunnels. At its deepest point, the tunnel sits 75 meters below the seabed, under the crushing weight of the ocean. There is no passport control inside the tunnel. Passengers cross the border at 160 kilometers per hour. In May 1994, the Channel Tunnel was officially opened, hailed as one of the 7 wonders of the modern world.
The Channel became a vital artery for trade, carrying over 25% of all goods traded between the UK and Europe.
To keep traffic moving, engineers carved out massive crossover chambers, some of the largest man-made caverns in the world. Maintenance never stops. Every night, teams inspect every inch of the tunnel to ensure it stays safe for millions of travelers. High-speed trains generate immense heat. A massive cooling system pumps chilled water through miles of pipes to keep the tunnel cool. At high speeds, air friction creates a wall of resistance. The tunnel's shape is designed to minimize this drag.
The central service tunnel acts as a safe haven, pressurized to keep out smoke and heat in case of an emergency.
By bypassing the slow ferries, freight trains saved hours of time, revolutionizing the European supply chain. The Earth is unpredictable. Engineers often had to adjust their plans in seconds to deal with unstable rock layers. Massive fans constantly push fresh air into the tunnel, ensuring that passengers always have breathable air deep underwater. The tunnel consumes as much electricity as a small city, powered by massive substations on both sides of the channel.
The tunnel is a high-security fortress, protected by advanced monitoring systems and constant patrols.
Trains are powered by 25,000 volts of electricity, allowing them to maintain high speed even on steep inclines. What to do with millions of tons of dugout rock? Engineers created a brand new coastal nature reserve. Most TBMs were dismantled, but one was simply steered off course and buried forever under the sea. Every second, thousands of sensors send data to the control center, monitoring everything from temperature to vibrations.
The tunnel didn't just connect two coasts, it connected two of the world's greatest cities like never before.
Decades after its opening, the Channel Tunnel remains a symbol of European unity and human ingenuity. Compared to flying, the tunnel is a green hero, drastically reducing the carbon footprint of cross-border travel. The tunnel also made life easier for pets, allowing millions of animals to travel with their owners every year. The lessons learned here have paved the way for even more ambitious tunnel projects around the world.
Saltwater is the enemy. Constant battle against corrosion is required to keep the steel structures from rusting away.
Passengers often forget they are deep beneath the ocean, traveling in a silent, pressurized cocoon. Over 20 million tons of freight pass through this underwater artery every single year. In case of a total blackout, massive backup generators can keep the tunnel's essential systems running for days. New technology continues to push the limits of speed and efficiency in the world's most famous tunnel.
The Channel Tunnel stands as a monument to what humanity can achieve when it refuses to accept the word impossible.
While other tunnels are longer, the Chunnel holds the record for the longest undersea portion of any tunnel on Earth. In just 35 minutes, you emerge into a different country, a different culture, and a different world. A $15 billion miracle that turned an impossible dream into the journey of a lifetime.
The world of engineering is full of wonders. For more mind-blowing documentaries, subscribe to True Facts World.